Welcome back to Elements of Chemistry. Today we're going to talk about density. Density is an intensive property of matter. That means it's going to stay the same throughout the sample of matter. Density doesn't change. If you take a sample of matter, the density is going to be the same throughout it. So if you took a bar of steel and you cut it in half, each half is going to have the same density. Take one of those halves, cut it into thirds. Each one of those thirds is going to have the same density as the original material had. So if we look at density here of some common substances, air being a mixture has a really low density. If we look at this chart, you can see gold has a very high density, a density of 19.32 grams per cubic centimeter. That's one of the ways that you can tell that gold is gold. It feels really heavy, or even platinum. Look at platinum at 21.3. And we're getting heavy rain here. So you may hear some rain in the background. Density is calculated value, not a measured value. So we have to calculate density, and we use the value or the formula density equals mass over volume. And I always like to teach this as density broke my heart. If you draw a heart, pen here to work, and you break it in half, you can see that that's an M over a V. So we say that density broke my heart. And it's just a way to remember density. So density is a measure of the packing of the particles. Things that have a low density are going to have a few particles per volume. And if it's got a high density, the particles are tightly packed in. So you can probably make the assumption that a gas is going to be low density because there's a lot of space between the particles, and solids would have a higher density. So let's look at water. Liquid water, we measure its density at 4 degrees Celsius. That's when it's its densest state. And we say it has a density of 1.000. That's a fixed standard. That's part of how we set the metric system because everybody on Earth has the ability to get pure distilled water at 4 degrees. Ice, as a solid water, it's still water, has a different density because ice has hydrogen bonding, which actually pushes those atoms and molecules of water, further apart. The hydrogens are going to link up with oxygens in the neighboring water molecule, and that's why we get those beautiful snowflake shapes. Okay, the other thing with density people always ask about is floating versus sinking. An object will float if it's less dense than the object it's placed in. For example, a log is less dense than the river it is floating in. Specific gravity is another term that we're going to have. It's a relative density of an object compared to a reference object. Commonly, water at 4 degrees is used as the reference state. So we're always comparing the density over 1. The specific gravity is less than 1, the object will float. If the specific gravity is greater than 1, the object will sink. So let's look at how to solve for density. Like we said, density is mass over volume. And let's look here. So if we were going to solve this equation for mass, we would look at it and go, okay, we need to isolate mass. If it's mass, pen doesn't want to really write clearly here, mass over volume, I've got to undo that division by volume. So I'm going to multiply both sides by V. So density times volume equals my mass. And that's one way to look at this formula. We tend to like density as mass over volume. If I needed to solve this for volume, well, I would look at this mass equation here. Density times volume equals mass. If I take and divide both sides by the density, I would have volume by itself because the densities will cancel. So volume is mass over density. Some people may give you like a triangle or a little circle with cutouts. It's easier if you just use the algebra and remember the algebra. To undo a multiplication, you divide. To undo a division, you multiply. What you do to one side of the equation, you do to both sides of the equation. So let's try some density problems together. What is the density of a metal sample that has a mass? So we know our mass is 125 grams, and we know our volume is 600 centimeters cubed. Well, if density is mass over volume, and I'm going to demonstrate proper way to do this, that's a V. You always identify your variables, set up your equation. This is the way we're going to solve it. So we're going to have density is 125 grams divided by 600 centimeters cubed. We'll take out our calculator. 125 divided by 600. And now we need significant figures. Well, 600 only has one significant figure in it. My answer came out to be 0.208 with a 3 repeating. With one significant figure, I'm going to call my density 0.2 grams per centimeter cubed. To make it stand out, I'm going to box that answer or highlight it. Okay, here we want to find the mass of an object that has a volume of 600 milliliters. So we know our volume. And it has a density of 0.97 centimeters cubed. And we want mass. Well, I've got mixed volume units. That should be grams per centimeter cubed. I lost the grams in there, sorry. Okay, we've got centimeter cubes and milliliters. Remember, 1 milliliter is the same as 1 cubic centimeter. So I can go in here and actually change that milliliter to a cubic centimeter. If density is mass over volume, if I want to solve this for mass, I'm going to multiply both sides by volume. Those are going to cancel out. Volume times density equals my mass. So I'm going to have 600 centimeters cubed times 0.97 grams per centimeters cubed. This kind of looks like a dimensional analysis. Our centimeters cubed are going to cancel each other out. We're going to take 600 times 0.97. Once again, that 600 only has one significant figure. My mass came out to be 582 grams, but if I want to do this in sig figs, it's going to have to come out to be 600 grams. Because 0.97 is really close to 1. Find the volume of a sample of soda that has a density, so we know our density. And we have a mass of 125 grams. I've identified my variables. If density is mass over volume, write it this way. If I need to solve that, let me write it the way you're used to seeing it. I need to get volume by itself. Well, I know that volume times density equals mass. Volume is mass over density. So I take my mass, 125 grams, divide it by my density, 1.2 grams per milliliter. The grams are going to cancel. 125 divided by 1.2. Now this time I want two significant figures because 1.2 only has 2. So I came out 104.16 repeating. Well, to get 104 with two significant figures, I'm going to have to put this in scientific notation because I'm going to look 1, 2, look to the right. That 104 is going to have to round to 100. So I'm going to call that 1.0 times 10 to the second power, and 1 over milliliters is the same thing as milliliters. So now it's your turn. Find the density of a bone sample that has a mass of 350 grams and a volume of 389 milliliters. Go ahead and stop the video, solve this problem, and come back when you're done. Okay, hopefully you've done that. You stopped the video, and now you're back. We want to find density. Density is mass over volume. Let's identify our variables. Our mass is 350 grams. Our volume, 389 milliliters. If we're going to take our 350 grams, we're going to divide it by 389 milliliters. We're going to get a unit in grams per milliliter. And we have 350 divided by 389. Now I want this to two significant figures. This came out to be 0.89974 and a whole bunch of stuff. Start at the big end of the number. 1, 2. Look to the right. That 9 is going to make this 9 go up. So we're going to have 0.90 for two significant figures, grams per milliliter. Hopefully you got that. Okay, here, look at this one. Try this one. Determine the mass of a sample of aluminum that has a volume of 675 cubic centimeters and a density of 2.6 grams per cubic centimeter. Stop the video and try this problem. Come back when you're done. Okay, hopefully you tried it. You didn't just wait the video. We want to do density. Density is mass over volume. We want to solve this for mass. So density times volume equals my mass. I give myself much room to work here. My volume was 675 centimeters cubed. My density, 2.6 grams per centimeter cubed. Now, when I write my variables down, that's when I check for sig figs. So I know I'm going to want 2 sig figs in my answer. I'm going to take 2.6 grams per centimeter cubed, and I'm going to multiply that volume, 675 centimeters cubed. The cubes are going to cancel each other out. 2.6 times 675. And I want 2 sig figs. Well, this came out to be 1755 grams. I want 2. 1, 2, look to the right. So that 1,755 is going to come out to be 1,800 grams. And remember, this only has 2 significant figures because those trailing zeros aren't measured. Okay, so this works really great when you can get a direct volume. But what happens if you've got an object that's a weird shape? Like here we have a bolt. How do we get the volume of that bolt? Well, we do it by water displacement. You take a graduated cylinder and you put a known amount of liquid in and drop your object in. Now, one of the things you've got to be really careful about is trapped air bubbles. You're going to want to tap that graduated cylinder to release air bubbles. That will greatly increase your accuracy because air is going to want to stick to that. And you just use water displacement, and that'll give you your volume. I hope this quick little video helped you, and as always, stay curious, be kind, and have a wonderful tomorrow.